Hi, hello. Welcome back. Let's move on to the next chapter, chapter 8. In chapter 7, we have learned how to use an array. All those array have the one dimension. So which means we can use the array to save a collection of the same data type, same type of data. Suppose I save 100 integers or 100 doubles in a vector. Okay, so that's what we defined. We call it a 1D array. In chapter, let's study the high-dimensional array. First one, let's start from the 2D array. Two-dimensional array, we can understand is the array of arrays. In other words, we have an array. Each element in the array is an array. Okay, we can use the 2D array to save a matrix or a table. You can understand we put all the elements in a table, and we can access the elements by the row index and the column index. First one, let's start from a basic array here. This is one way we can define an array, a 2D array. Because it's 2D array, we put the two brackets pairs. 1, 2. The first one represents the row index. The second one represents the column index. So suppose here, I define a 2D matrix with 4 index. Okay, 4 rows and 3 columns. Here, check the results. I put 1, 2, 3 in the first row, 4, 5, 6 in the second row, 7, 8, 9 in the third row, and 10, 11, 12 in the last row. So right now I have the 4 rows and 3 columns in this 2D matrix. So I can use the index, the row index, and the column index to access each element. And at this time, we also have the length, because it's an array of arrays, right? So if I put the matrix, the array dot length, this length means we would like to know how many rows, the number of rows. And this one means we would like to know the length of the first row. Okay, so which means the number of columns. And we can use the row index and column index to access a specific element. Suppose I have the 1, 2, means I would like to have the first row. The index is 1, the second row, and third column, the index is 2, right? So it's 6. Let's check the display function. I defined a display function here. See here, this function takes the 2D array and do not return anything. I'm using the 2 for loop, external for loop and the inner for loop, to loop through the whole matrix, actually the 2D array. The external for loop to represent the row, the inner for loop to to represent the column. So I put the ig to represent each element. Okay, there's one way we can initial 2D array. And the next way, let's check the regular way. Like last time we have learned, we can use a keyword new to create the new memory on your computer. So then we can save the elements into each memory slot. So check here. We give the 2D variable, right? We can use the integer, the new integer. New means we would like to create the integer objects for 3, which means we would like to create the 4 times 3 array. Okay, so I created a initial function. Check what I did here. There's nothing special. This initial function takes a 2D variable matrix. Okay, return nothing. Okay, I'm using the for loop to assign a random number to each element in this 2D array. Okay, let's check the next code. Next code, check here. Let's start from the main function. Here I call the initial function, init function, to create a matrix with 3 rows, 4 columns, and display this matrix. Then I call the sum function to calculate the summation of the elements in the 2D matrix. Okay. Let's start from the init function. This init function, I take 2 parameters, 2 integer parameters, row and column. So I'm using the new keyword new to allocate the memory for the 2D matrix. Okay. Then I'm using the 2 for loops to give each element a random number. At the end of the function, I return this variable. Okay, check here. This will return a 2D matrix. Okay, then I display the whole matrix. This one is exactly the same as the previous code, nothing special. And I defined a function called sum. This sum function takes the 2D array. Then it's nothing special like the 1D array. I just go ahead and create a variable s to save the summation. And then I'm using the 2 for loops to get the summation of all the elements in this 2D array. At the end, I return the value of this 2D array. Okay, that's the 2D array. There's nothing special. You can see 2D array is more like we define array inside the array. Okay, so which means we have an array. Each array element actually is another array. Okay. It's possible we have a 2D array, but each row we have the different number of elements. We call those kind of 2D array as a ragged array. Okay, so let's check how do we play around a ragged array. We can initialize the array like this way. The first column, I have the 3 elements. Okay, I gave the 1, 2. The second, oh no, sorry. The first row, I have the 3 elements. Second row, I have the 2 elements. Third row, I have the 6 elements here. Check here. In the memory, it's supposed to be like this way, which means each row, I have the different number of elements. And I called the same function to display the functions. Here I'm using a function called info to print out the length of each row. Okay, or check here. The standard way with how to define a regular array is like this one. Okay, I define a 2D array, and we are using the new keyword new to allocate the memory. But instead of we give the numbers, we leave the second index as empty. Suppose here, I define 3 row 2D array, but I leave this piece as empty because I don't know. So far, I don't know how many elements in each row. Then for the first row, I allocate 3 integer slots. For the second row, I allocate the 2 slots of integers. The third row, I allocate a single integer memory. Okay, then I called the init display to give the values. Okay, I'm using the init to initialize the regular array. Then I'm using the display function to display the whole matrix. Okay, I prepared the 2 exercises. You can go ahead to practice the 2D. Just remember 2D array, there's nothing special, just the array of arrays. Okay. Since we have learned the 2D array, it's possible we have the higher level array. Suppose we define 3D arrays. Okay, you can understand that each 3D array is the array of 2D arrays. Okay, in other words, once I define array, I can understand the first index as the page, the second index as the row. Okay, the last index is column. Okay, that's how we understand a 3D array. We have the page 0, page 1, and inside each page, we have a 2D array, row, column. Okay. Check here. I defined a 3D array. Then I'm using a display function to display the 3D matrix. This 3D matrix, I have the 3 levels of for loop to show all the elements of one array. Okay, or you can define the matrix like this one. Here I'm using the new keyword new to define a matrix have the 2 pages. Each page is a 3 times 4 2D array. And check here, I'm using the initial function. This is initial function. I have the 3 layers for loop to give each element a random number, and the matrix dot length to represent the number of page. And this one to represent the row in each page. And this one to represent the number of column. Okay, let's stop here. This is everything we would like to cover of chapter 8. Thank you.